Okay, let's continue the explanation. Wait for me to open this drawing. We will still talk about the English version. Yesterday we talked about the power part. This is the English version, so we use English annotations for all the English versions. We add this drawing and insert the picture. Yesterday we talked about the power part, A412. This is A412, Tata Bile A412, a model we often see, equipped with C4. 2C6, 4C6. Common models include 320D, 312D, and so on. Common models such as 320D, of course, there are many, including the Perkins version. All use this. What we talked about yesterday is the power supply part. Today, let's start by reviewing the power supply part. The gray port, let's start with the port. The gray port is the blue port. Gray-blue, 64 roots, 64 roots. Foot blue interface. Copy, a copy. Put it here. Use the format, brush inside. This Greek elector Konica is right. There are 64 pin on the right side, 64 pin, 64 pin. On the right side is also 64 pin, 64 roots. Foot, this side is a blue. Here is a blue one with 64 pins. Here is the battery input, 24V input. When we turn the key switch to ACC after opening ACC, this pin is ACC. When these three power supplies are connected, there will be power. This board can be powered on. After the power is on, we discussed this position yesterday. This is the main voltage regulator, the switch chip. We indicate the location of this switch chip here, U21. This is an important component that regulates the voltage. It plays a crucial role in the functioning of the board. Let's take a look at the main switch chip of the control transformer. Let's take a look at this translation. Let's take a look at the DWM control chip, DC to AC here. This is the transformer control transformer. These two are the ones we talked about yesterday. These two can be seen here. These two are the transformer. I forgot to label this as science former yesterday. Then we also label it as former in here and directly arrange it here. When it comes here, we will connect the whole cow level to the voltage regulator first, then convert it from DC to AC, and then convert it from AC to DC. After going through these three, it becomes the main 15V, which is about 14V. This 15V is the output for the capacitor. It is annoying to save this. These three below are a group, and there are 5 below that are a group. The following 5 are the main bubble juices. These 5 are the freezing point relationship. 3 of them are freezing points. This one is the main one. Yesterday we talked about the power supply part. Which one is here? You can see 3 of them. These 5 are 7 volts. Let's take a look. These 5 are selected. You can see that the highlighted part here corresponds to these 5. And one of these 5 is the one we just didn't select. It should be this one that is not selected. Below are these 3, and its filtering capacitor is the main airbag of this filtering capacitor. We did it yesterday. After it is converted from DC to AC, it passes through a vibrating current diode and a 7V filter capacitor. Then, this 15V main power supply is mainly used for some I/O ports. For example, if we need to use a group of 15V main power supply to power some business switches. Yesterday we discussed the external output sensor power supply, mainly 15V for the main power supply, and I/O 15V for some I/O power supply in and out 15V. These 3 are connected in parallel, called PCS parallel connection. This is a good combination of 5 parallel and 5 parallel. Yesterday we talked about the external output of 30 GV. This 15V is not used. The 30 GV is mainly used to drive the MOS tube. So we found this one external output. On the rear side, we are able to see this small object at the back. Please come to this location, VCC6 to QCL, jump to component QCL. Let us find this chip and check the output of its several pins. We have the capability to inspect all of the pins, including pin number 3 on the chip, for thorough examination. 1, 2, 3, let's take a look at the position of the foot. We can measure approximately 30 volts at this particular position. On the front side, we can measure around 30 volts. This set of voltages is also highly significant and should not be underestimated. Well, let's start with this specific position. We activate the power to turn on the comparator, U38, which is responsible for powering up. This small chip plays a crucial role in the power on comparator, the power on voltage comparator ACC, and can be found as a device in this location. It has a voltage comparator. After turning on, the system will have electricity. This is the main control chip. Let's see which chip is responsible for the output of 5V to 7V to 5V 7V to 5V. Yesterday, we discussed the moment when 7V is converted to 5V and then 5V to 3V. This moment 5 turns 3. This moment 5 turns 3. 7 to 5, 5 to 3. This main 7 turns 5. We also talked about a STANDBY definition yesterday. This 5TO5 turns 3 again. This is 7V to 2.5V. the type we discussed yesterday, which is the main 7V converted to 2.5V. Then these three are part of the entire cow diode. Let's examine this whole cow diode. There are three of them, 1, 2, and the two large ones are the cow diodes. Let's not worry about the one below for now. Let's focus on these two cow diodes. This one also looks like this, and these three are all cow diodes. Let's list them here. The voltage mentioned yesterday was mostly finished, and there are a few sensor voltages that are externally output. This is the main air amplitude conversion 5V, and this is the air amplitude conversion 5V that provides power to this sensor. There is a problem with this sensor's 5V, such as boost pressure and rail pressure. Let's take a look at this sensor that converts 5V. Click here, and this one will be highlighted. It is located in the middle of the hole, close to this hole, and has a 5V output. 7V to 5V for sensor. So there is an additional one that can be converted to 8V. We mentioned yesterday that there is another one that can be converted to 8V. Who is it for? It is for Turandot and crankshaft. This one here, it is 8V8V. It comes from 15V, and it is correct for Corinthian applications and installations. This is almost the entire power supply, without any marking errors. We haven't talked about the high voltage part of the entire power supply yet. This is almost the low voltage transformer part. The high voltage part is in this position. We will talk about it tomorrow. Today, let's mark this place well. This place is the power supply part, power part. Today, we will talk about so much.